All right, so for the Calculus 2 test, let's continue 9.6 talking about the root test. You know, like I'm saying, the Calculus 2 test. It's the Calculus 2 class, okay? So we're talking about all these tests. Okay, so what is the root test? Well, basically, you know, you got a series. And what we're looking at is the limit, as n approaches infinity, of the nth root, okay, of the absolute value of the series. And this is obviously handy if you've got something raised to the n power, right? Because the nth root gets rid of the n power, and that solves that problem. Also, the absolute value gets rid of alternating behavior, so we don't have to worry about that. And this is also going to be then a test for absolute convergence, okay? So if this thing is strictly less than 1, we have absolute convergence. Again, we have the same situation as before. If it's greater than 1, it diverges. And if it's equal to 1, okay, it fails, just like the ratio test, all right? So root test equal to 1, you can't make any conclusions about it, okay? This is how it works. Let's look at a problem here in the book. Those are the root test problems. Let's look at 49. 1 over n minus 1 over n squared to the n. Okay, so 49 looks like this. 1 over n minus 1 over n squared to the n, okay? Now the ratio test is a very, very powerful test, and you'll use it a lot. It's kind of a go-to test, right? Typically, you try the nth term test because it's quick. If the nth term test is not zeroed, it diverges and you're done. If it's 0, then you don't know, you can't really make any conclusions. You know, ratio test is usually what we go to then. Unless it's obviously geometric or something like that. Root test, you know, not very handy unless you've got that nth exponent right here, right? So to do this, what would we do? We would take the limit as n approaches infinity of the nth root, right? Absolute value, 1 over n minus 1 over n squared to the n power. Okay? Now, 1 over n is always positive, and 1 over n squared, this is always going to be less than 1 over n, okay? So this thing is positive, so we don't need the absolute value in this case. But anyway, the nth root gets rid of the exponent, okay, and we end up with the limit as n approaches infinity of 1 over n minus 1 over n squared, okay? We can multiply this top and bottom limit as n approaches infinity. I'm just taking the fact that we're subtracting fractions here, right? We get n over n squared minus 1 over n squared, right? So we end up with the limit as n approaches infinity of n minus 1 over n squared. And since we're going to infinity, we can just forget the negative 1, okay? So this is basically the limit as n approaches infinity of 1 over n, right? Because if we get rid of the negative 1, this n and the n and the square is going to cancel. It's going to cancel with one of the n's. And this limit is obviously 0, so this thing converges absolutely, right? So this is absolutely convergent by the nth root test. Try these problems. If you get stuck on anything or have any problems, send me a question via email, and I'll try to address them.